Namaste dosto. Have you ever thought about how much paper is needed to wrap a birthday gift or how much water fits inside a bottle? These everyday questions are exactly why understanding surface area and volume is so important. Whether you're helping pack snacks or building a model bridge, knowing how much space something covers on the outside or how much it can hold inside makes all the difference. In real life, we deal with shapes like cylinders, cones, and spheres all the time. Think of a cylindrical water tank, a cone-shaped ice cream cone, or a soccer ball that's a perfect sphere. Designers and engineers use these shapes, and sometimes combinations of them, to make everything from packaging to building safe and efficient. To figure out exactly how much material we need to build or how much space an object occupies, we calculate surface area and volume carefully. But objects in the real world aren't always simple. Often, they're made up of two or more shapes combined. So, we often split complex objects into familiar parts like cubes, cylinders, or spheres to tackle the calculations step by step. Shabash. Keeping these ideas in mind will help you solve many practical problems ahead. Now, let's shift gears from the flat world of 2 dimensions into the solid space of 3 dimensions. Imagine a square drawn on paper. That's an area, the amount of surface it covers. But what about a cube, like a dice? Surface area measures all its 6 faces added together, showing how much space wraps around it. Volume, on the other hand, measures how much space the cube takes up inside. It is expressed in cubic units, like cubic centimeters or cubic meters. For example, if we say a box has volume 50 cubic centimeters, it means it can hold that much space inside. So, how do we find the surface area of a solid? We add up the areas of all the flat or curved surfaces it has. And units matter. Area is always in square units, like square meters or square centimeters, because it's 2 dimensional. Volume is in cubic units, like cubic meters or cubic centimeters, because it covers 3 dimensional space. Think of it this way. Area is like painting the walls of your room, while volume is like filling a tank with water. Arey vah! Recognizing the difference between surface area and volume is a key step toward mastering 3D geometry. Next, let's look at the types of 3D solids we'll focus on in this chapter. These are the familiar friends of geometry with smooth and regular shapes: cylinders, cones, spheres, and hemispheres. Each one has its own unique features and formulas for surface area and volume based on their shape and symmetry. For instance, a cylinder has 2 circular bases and 1 curved side wrapped around, like a can of soda. A cone has a circular base tapering smoothly to a point on top, just like an ice cream cone. A sphere is perfectly round, like a basketball. And a hemisphere is exactly half a sphere, like the shape of a ball. Sometimes, things get more interesting when these solids are combined to form composite shapes. Imagine a shape made by putting a cone on top of a cylinder, like a traditional hat. To solve problems with these, we split the composite solid into its standard parts and then find surface area and volume separately before adding the results. Excellent beta. This way of breaking complex shapes down makes calculations manageable and clear. As we dive into these calculations, a quick reminder: units are super important. Whether you're measuring surface area or volume, using the right and consistent units is crucial. Surface area is always reported in square units. That means if you're measuring in centimeters, your area will be in square centimeters. If you switch to meters, then it's square meters. Similarly, volume is measured in cubic units, like cubic centimeters or cubic meters, because it involves all 3 dimensions. Watch out for mistakes here. Mixing units, like using centimeters for length but meters for width, can cause big errors in your answers. Sometimes, you'll need to convert between units. For example, since 1 meter equals 100 centimeters, converting requires multiplying or dividing by the right powers of 10 to keep measurements consistent. In real life, volume is often given in liters or milliliters, especially for liquids. Remember, 1 liter equals 1000 cubic centimeters. So if you know the volume in cubic centimeters, you can easily convert it. Keeping your units straight and consistent helps you avoid confusion and get accurate results every time. Shabash. Let's wrap up what we've learned in this introduction to surface areas and volumes. Surface area tells us how much outer coverage a three-dimensional solid has. We measure it in square centimeters or square meters. Volume tells us the space inside an object, like how much water fits in a jug, and is measured in cubic centimeters or cubic meters. Key points to remember. The difference between 2D and 3D measurements helps us understand space and shapes better. Each standard solid, cylinder, cone, sphere, and hemisphere has its own formulas for surface area and volume that you should memorize. And above all, keep your units consistent throughout all calculations to avoid mistakes. When we deal with composite solids, these complex shapes made of simpler ones, our job is to split them into these basic solids and calculate each part carefully. Excellent understanding of this will give you a great foundation to solve many real-world problems efficiently. Areva, keep practicing, and you'll soon master the art of 3D geometry.